Some of the largest industrial operations in Brazil don't happen inside a factory. On the coast of Rio Grande do Norte, in places like Macau and Areia Branca, the ocean itself is the workspace. Seawater flows into these shallow tanks as a single, clear liquid. Even though there is a massive amount of salt in that water, it's so well blended that you can't see a single grain. The water just sits there, taking in the heat of the sun and the steady coastal wind. These two forces work together to slowly pull the water into the air as vapor. As the water leaves, it can't take the salt with it. The salt stays behind, gathering on the floor of the tanks until it forms the solid white crystals we see in these mountains. This process of letting the liquid vanish to leave the solid behind is called crystallización. Most of the salt that seasons your food across the country started in these coastal backyards, separated from the ocean by nothing more than the sun and the wind. Every mixture can be pulled apart if you can find one way the ingredients behave differently. Here, the water can turn into a gas, but the salt cannot. By letting the liquid escape, we trap the solid. We do this same kind of work every day in our own homes. When you make a pot of coffee in the morning, you aren't just making a drink, you're separating a mixture. You pour the mixture into a paper or cloth cone. The dark liquid flows through the material, but the solid grounds are stopped in mochaks. The logic here is simple: size. As we see here, the holes in the filter are large enough for water to pass through, but much too small for the grains of coffee. In science, we call this filtration. But there is a limit to this method. If you tried to filter the seawater we saw earlier, it wouldn't work. Once salt has dissolved, its particles become so small that they slip right through the filter along with the water. Filtration only works when the solid hasn't dissolved, when the particles are still large enough to be caught. Now, consider a different problem: a jar of water mixed with sand. You can see the grit swirling around, making the water cloudy and dark. You don't need a filter for this. If you just leave the jar alone, gravity does the work for you. The sand eventually sinks to the bottom, leaving clear water at the top that you can carefully pour away. This method of letting things settle is called decantation. It works because of density. The sand is heavier and denser than the water, so it sinks. This creates a clear boundary between the two materials, allowing us to separate them just by waiting. But what if you have two liquids that are perfectly blended together, like the alcohol and water in a batch of fermenting sugar? There are no grains to filter and no layers that will settle over time. This is where the copper alembic comes in. It has been used for centuries to solve this exact problem by using a fire. As the mixture heats up, the two liquids respond differently. One of them will reach its boiling point before the other. That liquid turns into vapor and rises, while the other stays behind in the pot. That vapor travels up and into this cooling coil, moving away from the heat of the fire. As it cools down, the vapor turns back into liquid drops. By the time it reaches the end of the tube, it drips into a separate container, completely isolated from the first liquid. We call this distillación. It relies on the fact that every liquid has its own specific boiling point. By using heat, we can untangle liquids that seem impossible to separate, just by finding the temperature where one wants to fly away and the other wants to stay. Whether we are using a filter, a settling jar, an alembic, or a salt flat, the goal is always the same. We are simply looking for a physical difference. We use differences in size, in weight, and how things evaporate, or the temperature at which they boil. You've been doing this for years, every time you strain pasta or wait for the dirt to settle in a bucket of water. Now you have the scientific names for those actions. But once we have separated these ingredients, how do we know exactly how much of each one we have? To answer that, we have to look at the weight and the space things take up. Because in science, to measure is to know.